All right, so we're looking at our notes, and we're gonna look at this warm up here, and it's evaluating these negative exponents and zero exponents and exponents of 4. So what we saw last time we took notes was that when you have a negative exponent, it makes a fraction, and then it would be a 5 to the second on the bottom. So it's the same exponent 2, but now it's in the bottom. So this is equal to 1 over 25. If it's just x, we don't expand it to 25. It's still a fraction, and it becomes 1 over x, and then the exponent was 2, and the negative has moved it to the bottom. Anything to the 0 power is equal to 1, so that's super fun. And x to the 0 power would also be equal to 1. Saying anything that has exponent of 0. What's the difference? What if I had 5 times x to the 0? Well, that would become 5 times 1 because only the x had the 0 power. What's different than that? Notice this one, 5x in parentheses to the 0. Now the whole thing is to the 0 power, and that would mean the answer to that one is 1. For 5 to the 4th, that has the meaning 5 times 5 times 5 times 5, and we can use a calculator here. This would be 25 times 25, and what do you get? This is equal to 625. Our last one is x to the 4th, and just to practice expanded form, that means that there are 4 x's. 1, 2, 3, 4. I almost messed that up. And so what we're gonna look at on 4.4.1 is looking at expanding these and then looking to simplify them. And so let's take a look at these first few. So it says x to the 3rd times x to the 7th. I'm gonna give you time to do this on your own. This is gonna be x to the 3rd, 1, 2, 3, and then x to the 7th, 1, 2, 3, 4, 5, 6, 7. And then if we're looking at the simplified form, let's see, there's 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. So wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the simplified form is x to the power of 10. This is a hard one, so let's do this one together. This one says x to the negative 4. So that's 1 over, and then 1, 2, 3, 4, times by x to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we want to remember here is that maybe some of these will cancel out, but it's a 1 for 1. Okay, whoops. So then what's going to happen here is we have some on top and some on the bottom, so even 1 for 1 will cancel. 1 for 1 will cancel, 1 for 1 will cancel, and 1 for 1 will cancel. So these all on the bottom all canceled out, and then I have these left over. 1, 2, 3, 4, 5, 6, which means I can write this is x to the 6th power. At this point, we do want to pause the video and let students, I want you guys to try these on your own to try to get the simplified form. The goal is to look for the relationship or like the pattern to go from here to here. On this one, you can be creative, and then this is where you're going to put in the rule. Okay, so this one, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4 together is x to the 10th also. For this one, 1, 2, 3, 4, 5, and 1, 2. Together there's 5 plus 2, 7. For this one, 7, 1, 2, 3, 4, 5, 6, 7, and 8, 9. This is x to the 9th. This one is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So 3, 4, 5, 6, 7, 8, 9, 10 again. So for 15, what are some choices we have? This could have been x to the 5 times x to the 10. It could have been x to the 4th times x to the 11th. Maybe it was x to the 3rd times x to the 12th. And we could have a couple more. Maybe we have x to the 8th times x to the 7th. So any combination like these would work. What do these all have in common? Well, 5 plus 10 is 15. 4 plus 11 is 15, 3 plus 12 is 15, and 8 plus 7 is 15. This one is a little bit sneaky. So looking at this x to the 4th, this one is 1, 2, 3, 4. But remember, x to the 0 is times by 1, so this one is still x to the 4th. So what is the rule? X to the a plus b. And so the general rule with exponents with the same base and multiplication is to add the exponents. For example, x to the 3rd times x to the 4th would simplify to x to the 7th because you add the exponents. So now at this time, we're going to get out our handout and do a little bit of practice. We'll do some of these together, not all. This is our handout, and we can go through these and look at some so we can see. I'll let you do E on your own. Let's take a look at some of these ones over here in this quadrant, because even though this is the same rule of adding, there are more than one letter. So at the -6, that's -6, and here's u, and this is u to the 1st power. So for the u's, we're going to do 2 and 1. 2 plus 1 is 3. For the v, same idea. This is 1 and 2, v to the 3rd. So I'm looking for that. That is 13. So then for 13, I'll put my t. For this, 1, 2, 3, 4, v to the 4th. This is 1 plus 3, that's 4. Oh, fun. They're both the same, that's 3. So it says 3, I'm going to put E. So what we're doing, remember that when we don't see the exponent, that's 1. So we did a little practice with this in our polynomial unit. Now this one is different. I have 4 times 2, so I do still multiply those. That's 8. And then there's a minus sign here. So those are done. And there's 1, 2, so then 4 more u to the 6th power. Cross off my u's, okay, and then v plus v, that's going to be v to the 2nd power. So do I see that on here? That one's 12. So that's going to be I for 12. So this is how we get started on these. You can have fun. You can see that your answers will be here, so you can work together on this worksheet. When you finish this, there's an IXL for you to start. That's the same topic, so that will give you your instant feedback. Have fun. All right, so you guys, look at this. We're doing our next investigation, and here we're going to be looking at division. And so I have our first example here showing how we want to do this. And what you see is that we have x to the 3rd in the top, And so when we do the expanded form, that's going to be 3x's, and then x to the 7th on the bottom. 1, 2, 3, 4, 5, 6, 7. And what we want to do with these 3 here is see that there's equal number on the top and the bottom. So that means that this one cancels this one. They cancel each other out, each one. And so what we're left with is nothing on the top, which we have to put in the 1. And then there's 4 on the bottom. So one way we can write that is 1 over x to the 4th, or x to the negative 4, my 4 looks kind of weird there, as the final answer. And so here you guys have the guide, and we're looking at these. I thought there was one that was a little bit tricky on here. Oh, they're down at the bottom. And so I want you to go through these, see what you can, write them in expanded form like this, and then try to simplify it. So at this time you want to pause and try to work with your friends and neighbors, or at least just to figure out how to get the answers. So you want to do that right now. Okay, so we're back, and let's see if you got the final correct answers on these. So for x to the 7th divided by x to the 3rd, the final correct answer for that one is going to be x to the 4th power. Fun. For this one, x to the 5th divided by x to the 4th, this one is x to the 1st power. You don't need the 1. On x to the 4th divided by x to the 5th, that's similar, but you end up with 1 on top and x to the 1st on the bottom, which you can write that way, or x to the negative 1 power. For 3 and 2, you again get x. For 0 and 7, that's going to be 1 over x to the 7th power, or x to the negative 7 as the exponent. For 6 and 1, that's x to the 5th. For 3 and 8, that's going to be 1 over x to the 5th, which you could also write as x to the negative 5th power. For 10 and 5, that's x to the 5th. And so we've got 2 different ways to get x to the 5th. Here I wonder, could you come up with a third way or your own new way using different exponents? I bet you could. Let's see. Here's an example that I'm thinking of. I like 7. So I could have x to the 7th power divided by x to the 2 power. And so what is the pattern that's working here? These are the harder ones I'll go over with you. Hopefully you're seeing that the pattern is subtraction. This one is x to the 3rd power minus 7, and that's how we got x to the negative 4th power as our first answer. And remember, the negative moves to the bottom. On this one, we have x to the numerator is 7, so 7 minus 3, that gives us x to the 4th power. Fun. What about this one? This one was x to the 5 minus 4, and that's how we got x to the 1st power. Let's switch to navy. For this next one, this one is just the same. It's x to the 4, but then minus 5. So we're subtracting the exponents, and now the exponent is going to be negative 1 instead of this one, positive 1, because of the order. So whenever there's more on the bottom, one thing that I ask myself to do this math kind of in my head is, where are there more? Ignore that bell. Where are there more, in the top or the bottom? So in the top there were more, and then how many more? There were 4 more in the top. Where on the first question, there were 4 more on the bottom. So 4 more on the bottom, 4 more on the top. 1 more on the bottom, 1 more on the top. This one is tricky because of the 0. So x to the 0 power is equal to 1. Anything to the 0 power is 1. So that is just 1 over x to the 7th. And so that's what we have here. Or you can write it out as x to the 0 minus 7, and that's how we get the negative 7. So how do we get 5x to the 6 minus 1? So I think you're seeing the pattern, which is cool. So how would we do one that's got a negative exponent? So a negative with division, since we're subtracting, let's show using the rule. This one would be x to the negative 3rd power, that's the numerator, minus 7. As you can see, these are both negative, so we're going to add and keep the sign the same. That's going to give me x to the negative 10th power, or 1 over x to the 10th power. And so when we write it out this way with the law of subtraction, we can see that. The next one, let me erase this so you can see. This one has positive 3 and then negative 7 in the bottom. So you have x to the 3rd minus, and then it's a negative 7. So if we write out that minus sign, you can see that this created a double negative, and 2 negatives turn to a positive. So this is x to the positive 10 power. Pretty cool. So what does this mean for us? Overall, when there's a negative in the numerator, it's going to go down to the bottom. You can see that all of the x's are in the bottom here. When there's a negative in the bottom, it moves up to the top and becomes positive. Negative exponents are very tricky, so I'm going to give you an IXL with just negative exponents and exponents of 0. What is the law overall? The law is x to the a power minus b power. So the general rule with exponents with the same base and division is to, what did we do to the exponents? Not divide them, we subtract the exponents. For example, and this is where we can put an example from up here, or I can make up my own. I like the numbers 6 and 7. So if I had x to the 6th power divided by x to the 7th power, would simplify to 1 over x to the 1st power, because you subtract. And I can also write this as or x to the negative 1 power. And that's because x to the 6 minus 7 is equal to x to the negative 1. So at this time, we're going to switch to doing our worksheet, and we're going to take a look at some of those. So our worksheet is this yellow. Why are babies like hinges? So I love these. I know that they're kind of silly. They always have like a funny little saying. In this one, we're looking at, I'll let you guys do these ones by yourself. I'll go over just a couple from, let's pick the harder group. Let's see, we'll do number 9. I notice all these exponents are positive, so just in the IXL, well, you need to do those negative exponents. They'll give you that instant feedback. So when I look at number 9, first we want to group these. I see that these are some numbers. Let me zoom in here. And we reduce these like normal. They're both divisible by 3. So this would become 1 and this is 3. So I know that my answer is a fraction and I'm gonna have a 3 here. We usually don't need the 1, but I'll put it there just in case. Then I'm gonna practice using that law. And I'm gonna say, where are there more A values? So the next one I'm looking at is just the A. There's more A on the top. How many more? Well, 5 is 3 more than 2, or I can just do 5 minus 3. Minus 2 is 3. And so there were A to the 3rd on the top. Where are there more B values? On the bottom. How many more? This one is also B to the 3rd. So then the cool thing is my answers will just be somewhere over here. So I'm not gonna be too scared. I see the 3, and it looks like the answer for 9 is H. So I'll go down to 9 and I'll put down my H. Let's take a look at another one. Maybe we'll look at number 11. So here I have a negative, but 24 and 18, I can't divide them both by 8, but I can divide them both by 6. So when I divide 24 by 6, I get negative 4. 18 divided by 6 is 3. Then I'm looking at this one. A squared, and then just A, that's going to be 2 minus 1. That's going to be 1. So negative 4A to the first in the top because it was upstairs. And then when I ask myself, where are there more B values? Again, we're going to see in the bottom. And this is an exponent of 1. So there are 4 more in the bottom because 5 is 4 more than 1. Let's take a look at number 12. This will be our last one to do together, and then I'm going to ask you to work on this with your groups. For just the numbers, 30 divided by 2, that's still 15. And then where are there more A values? In the top. How many more? A to the third. 9 is 3 more than 6. And then where are there more B's? This would be B to the 0 power. Ha ha ha, that's a special one. B to the 0 power cancels out because B to the 0 power is equal to 1. So, oh, you can't really, I accidentally wrote over my answer. Sorry. The answer is 15A to the third power, which I see right here. So this is the correct answer. And so you can try these, give it a go. I hope you have fun, and you'll have an IXL to go along with this too. You can get started on this worksheet, and then once you finish this, please work on the IXL.